Okay, we're going to be looking at an example of total internal reflection. So I've got my situation here where I've got air and water, and this is the boundary layer. So light is going to want to leave the water to enter the air. However, it's going to be bent so much it comes back into the water. So it's always a good way. We're going to start off with drawing a normal, which is the right angle line to the surface, because all our angles are referenced to that. So here is my light ray, and it is leaving the water, and we're looking at the absolute critical angle, so it's going to just skim across the surface, right? Like a millionth of a degree more, and then it's going to be totally internally reflected. So normally this is a trick question, because when it's reflected like that, or refracted like that, it's actually 90 degrees. This is the angle of incidence, so we'll just label that. Okay, let's actually go ahead and calculate this one. So we have Snell's law. So sine I over sine is equal to n2 over n1. The most common mistake for students is, okay, what is the refractive index of these guys? And in the right place as well. So air is 1.003 and water is roughly about 1.33. Okay, so which one is N2 and which one is N1? Who knows? Well, it's quite easy. If you go down to here, you see that little one? If I just put a dot on it, it now looks like an eye. So I'm going to use the refractive index in which the ray is the incident, which is actually water. So N1 is actually water, and air is going to be N2. Alright, let's substitute our values. So sine of I, we still don't know what it is, over the sine of 90, which is equal to 1. And N2 is going to be the air, so 0.003, and the water is 1.33. And that actually calculates to be 0.754 roughly. Please note, until your final answer, you should keep all the decimal places in your calculator, and you'll nut it out later. So sine I is equal to 0.754. So I is equal to the inverse sine of 0.754. So I is equal to 48.95 degrees. Now obviously that's too many significant figures, so considering the angles that you've been given, roughly to two significant figures, so I'm just going to go 49 degrees, and that's all.